Hi, Srira. Good morning. How are you, Srira?
Hello?
Yeah, can you hear me?
Yes, I can hear you.
Okay,
Fine, how are you?
good. How about you?
I'm doing fine.
Okay, all right. So, yeah, Jesslyn has informed me that she'll not be in the class today. So she'll catch up with the recordings. So, did you have any questions so far? Anything needs more clarity? Or are we good?
I was able to follow.
Okay, okay. So yesterday we left with the hands-on. We will continue with that hands-on session today. Okay. So in the chat, I will share the SQLite browser sessions ID, or if you already have that, you can open it. Let me just onto the chat. Yeah, I just have pasted the link on the chat. You can click, go to SQLite browser, and yeah, let's go into. Did you get a chance to look at the MSQL script? This is actually a script which I put it on the Google Drive. Uh,
No, I didn't
no,
get to.
no problem, not a concern at all. So earlier we installed. Hold on, just give me a moment. We installed one editor for Notepad. Oh, okay. Let me see if we can. Yeah. So I'll just open it with Notepad. Okay. You can also do so. I will share this. I will share this with the chat as well. Uh, just give me a moment. Yeah, sorry about that. Um, I am going to send a script file through the chat, and then yeah, emp.sql. Now, all SQL files in terms of statements in SQL, what is an SQL file? A .sql file. It's just a text file which contains SQL statements. It's a text file which contains SQL statements. And in the SQL statements, like what we looked at yesterday, here I have opened it with WordPad. I mean, not the best of the editors, but uh, earlier we used some editors, right? So we could open it with any notepad or text editors. Okay. So here is create table department number. And the script has several SQL statements already. So script has uh, two tables which it defines or which it creates, the department table and the M table. Okay, these two tables are getting created. It's an empty table. It will have column definitions. And
Just
am I
you
sharing?
no, you're not sure.
Sorry. So meanwhile, yeah, hope you can see the extend class. SQLite interactive browser online. Are you able to see my screen?
Yes.
Okay. So this is the script which I shared on the chat. Okay, if you are able to get to the script in chat here, emp.sql.
Yes.
Yeah. So what the script is, it's a SQL script inside a .sql file. Emp is a name, .sql is a file extension, which is still a script file. Okay, it's nothing but a text file which contains SQL statements. So here you have that script file containing several SQL statements inside it. Several SQL statements. I remember Sublime Text. Right? Sublime Text can also open this. So Sublime Text can open, or any text editor can open. It's just a text file. So let me open this for again with Sublime Text. Allow me like that. Okay, so you'll see some, instead of a plain notepad, WordPad text file editor, I got it in I opened it with Sublime Text. Okay, m.sql. Hope you are at that point as well. Can you try it?
Yes, mine is open in a Sublime Text.
Excellent. So what we have here is it's got two tables shown green, department and M. This is a department table containing columns, department number, department name, shortly D name, and location, shortly LOC. Okay. And it has got a primary key constraint on this column, department number. So constraint primary key, primary PK, some name, primary space key within bracket department number, referring to this column, first column, meaning we're defining a primary key on the first column. The first column is a number data type. It's got two, which represents two digits. You can specify the number, or you can leave it just like number, it will take. Okay. So department name is varchar2. That means a variable character. Okay, up to 14 character spaces. If, let's say, department has sales, which is just 5 letters, 5 characters, remaining 9 character spaces will be left empty in the storage level, in the logical table. Okay, as the data is varchar, it means variable character. So it allocates only as much as data which is given into that particular field, that column. Sales is taking 5 letters, so 5 character spaces. The rest is blank. Okay. Whereas something like just char will allocate, just char itself is a data type of the column. So this is the data type of this column. Okay. You can also have it as char of 10. That means every record 10 character spaces will be allocated. Location, however, here is varchar of 13 in variable character. Okay. So it can go up to a max of that many characters. So there is department table. Create table department. That's the syntax. Open brackets, department number, department name, varchar2, location, like that. Column definitions are separated by a comma. After the comma is the new column name. After the comma, new column name. After the comma here, last one has a constraint. Primary key within brackets, that is primary key on this department number. And the last close parenthesis is here, and a semicolon, which indicates end of the state. So create table department. So this is one table. Similarly, M table, two tables getting created. We insert some rows and we query. Insert rows into, this is employee table, this is department table, DPT. Insert rows into the next table, M table, for all the employee information. And finally, we are just doing some queries from these tables uh, with join criteria and so on. Okay, so that's the scope of activity. Take this entire statement, create table department. Okay, well, we're going to paste it in the browser, extendclass.com, extendsclass.com, SQLite browser. So here you can just replace it. And run. When I do so, query has no result. That means it just did not give any response. If I refresh it, the table is getting created. So I just pasted the first statement, start from the create, end at semicolon, into this browser. The browser has this notepad region where you can paste it and click run. As soon as you do that, the database has the table, department table, department table. You can try the same. You can try the same. And
I got the table department.
did you refresh and get this table?
Yes.
Okay, very good. So table is created empty now. Okay. This is a data definition language. That means we're defining the table definition. We're not yet done anything with the data. We just created the table, a logical table. So since we're defining columns and giving it a name of the table and so on, this comes under what's called data definition language, or DDL. DDL in SQL. Rest inserts, update, and delete. These three operations are called data manipulation language. So DMLs, short for DMLs. Even select include DMLs, data manipulation language. So what we're doing next is we just, okay, here is the second table. We create the second table similarly. Copy from here. This has got create table M. M is the table name, shortly for employees. Open parenthesis, column definition, data type, field widths. Okay. Employee number, employee name, job, hire date. Date is a column data type. Salary, commission, and department number. Now, if you see the department number column is repeating, which is common between the two tables. Why? Because this is a primary key here, and over here the same column name is the foreign key. So here we have a constraint department number. Okay, this is our employee table. Employee table has employee number, which is unique, and employee number will be the primary key of this table, employee table. Each employee number column will have unique values. This is the column definition. So constraint pk m primary key within bracket emp number. Now constraint here refers to first constraint, second constraint. So first constraint is primary key of this table. But we also are defining foreign key. Foreign key. What is a foreign key? Department number references department tables, department number. So then when you include this constraint, of course, there's a comma here. When you include this constraint, we are creating a referential integrity constraint. That means the data here, if it is department number 10, here at employee table, you could have 10 multiple times. It does not check for uniqueness here. So that's a foreign key. Okay. The rest of the columns, employee name, job, manager, hire date, all of that is a date. I mean, hire date is a date data type. All the other columns are number or var character. Okay. So take the second one, create table M. Now, when you paste it below and you run, you'll get an error here because this table department is already created. So I don't need that. So I can remove it. Okay. Then if you run, no issues. But if you have to run a specific set of lines, you have to highlight that and run. Whereas no result is a default message. You highlight that and run and refresh. Here is their M table. You getting this far? E-name, varchar 2 of 10, which means that it's 10 character spaces. Just one moment. Just give me a moment, please. All right. So what I mean to say is I removed the department from the script area. This is the editor. So paste employee table, it's definitions here. Now what are the columns? Employee number is a number, 4 character. Employee name is varchar 2 is a data type, 10 characters, could have more. Job varchar, MGR is a manager number of the employee whose manager is under whom the employee is working. Manager number is the employee number of the manager. If you have one record, the manager of that employee can be seen by the number in this MGR column. Then you hire date, salary, commission, department number, constraints. So this is the second table definition. Hope you created that as well.
Yes.
Okay, very good. Now we start inserting rows. So here's insert into department, department number, department name, location, values. Okay, insert into department, DPT, open parenthesis, close parenthesis, the names of the columns in the order in which you would insert the data. So department number, comma, D name, comma, LOC, bracket closes here, and follows values. And then open brackets, 10, standing for department number, comma, accounting, standing for D name, comma, New York, standing for location. These three are column data values of this table's these columns. So these columns are getting populated with this data. So format is insert into and values. Okay, so I have similar ones. Insert into the same table, research, Dallas. So let's take these sequels, just the inserts. Pardon me. Go to the browser. I just copy, override. I paste the inserts. Boom. Right. So I have 4 records in the department. Each insert statement, I think I'll put one semicolon like that. You know what I do? I run. Okay, this is not required. Run. Unique constraint. Okay, something got inserted, so the constraint violation has happened. Let's see. 10 seems to be there. Already. I delete the record. Let me remove the record. So I removed the record by clicking department and it showed up the record. Then you highlight on it, you can delete. But here is how you insert the record. These 4 insert statements, you can keep it cursor anywhere and click run. Although you're not getting a visual feedback, 4 rows have gone into it. Just click on the department. Here it shows 4 rows. So that's the rows which are inserted into the department table. Here, these 4. And following that, let's close this to do a select star from department. So all this got inserted. Now let me just remove this. Select star from department. The query has now result run. So here is 4 rows. So if I do select star from department, star represents column 1, comma column 2 like that for all the columns. So select star from department. And you see the results. 4 rows are. Did you get this far, Sriram?
Yes.
Okay, very good. So this is now populated rows of the department table. Let's go create. Okay, employee table being created. Similarly, I have from row 42 insert into M values 38, sorry, 78, 39 is, you don't need the same column order, but it's an optional thing. Like here we put a column order. That's if you don't give the default operation, yes, it'll have certain assumption of the column data and the order. Okay, so insert into emp means without following brackets and open and close brackets, means it is not required to give the column names, and the column names are as it appears in the table. So values emp number 7839, name king, job president, null, date here, DDMMYYYY format, amount which is number, null possibly a varchar, and 10. So here, right, null is a number and 10. So this is a department number. This is commission. Okay, null is null means is an empty string in database terminology. Null here is a blank empty string. Okay, that's when you issue the data as null. Okay, so here copy this insert statements till row 67 from 42 to 67. And you just place overwrite it here and click run. Query has no result, so it's done the insert operation. Let's refresh here. M clicked on the employee table. After the refresh, here is your table employees being inserted. Okay. Table employees, employee name has now got 9 rows. It shows 9 rows. Did you get this far, Sriram?
Yes.
Okay, very good. So you got 2 tables which have got rows, and we queried earlier the department table. Let's even query the employee table. Okay, here is some more records. Miller, Clark, insert into M. I'll insert few more rows because there's 14 rows. They only created 7. So since I'm inserting new rows, I'm going to overwrite the earlier content and just straight off run. Query has no result, refresh. Again, refresh, you got 14 rows now in the employee table. How did it get there? Inserts. So you have the script, you can copy and paste it. Did you get the answer? Like just fetching 2 rows. Now if you query select star from M, onto the SQLite browser, close this, select A, run. 14 rows got selected. Select star from the table name EMP. So the command is select star from M. So we have selects which are now returning data. One is employee table, another is department table. So we do have 2 sets of tables which are shown here. Okay. Okay. Next, we will pick data from both the tables. By picking these 2 tables by the column name, you need to join the table based on the relationship. Here is the criteria. Okay. So select employee name, department name. These 2 are employee name is in employee table, department name is in department table. However, you can fetch them together here because it's specifying from 2 tables here, emp, comma, dept. So we are fetching columns, few columns from one table, few other columns from another table. we have a join, equi-join, the join between the M and the department tables with the criteria where M dot department number is equal to department dot department number. I repeat, there are two columns, two tables in the from clause in this select statement. The from clause has two tables, M comma department, where M dot department number is equal to department dot. So this is called a join. Table 1 dot the common primary key column is equal to table 2 department dot primary key column, which is a foreign key. So this is a join criteria. Two tables, emp and department, are joined this way. And once the result is there, you can order by employee name. Okay, so let's copy this. So where are we? I'm going to copy this and paste it here. So now watch. See, the columns have data. That's all we want because these two tables are joined. Okay, by the column employee number. Are you getting this? Sriram, are you able to get the output?
Yes.
Okay, so this is our result query. Okay, 14 rows select. Okay, very good. Next, this is an aggregate function. I want to count the number of employees in. Once I join these two tables, I want to give an output like count the number of department employees. So I want an output which shows sales has, let's say, 10 employees. Research has some 25 employees, like that. Okay. So each department is fetched first and then comma count star. And then count star. So this is an aggregate function, count. And when you're using an aggregate function, it should have unique output column data. So for example, department name occurs once in this query. And it'll give how many count is there. Department name, sales, there are 6 employees, likewise. So select dname, comma, count star, count of employees is alias. It's aliasing, not required, but he's doing aliasing, which is now the count star will have this as a column title. Column title for the count. I will show you. So these two tables, join criteria remains the same. Then group by, order by is also in that. So group by means you need a group by if in the SQL statement you're going to group by some column. So department name will occur uniquely once and its count will be shown. Order by is 16. Sorry, order by is 2 here. That means the second column. So what it does is order by 2 means count with the 2 here is second column. Sometimes the column can be referred by the number. So this result, order by 2 descending. So 2 is second position is count star. So if I have count star If a department has got maximum number, let's say 10 employees, then the largest number, that department should come first because order by to descending. Then the next department maybe has 5 employees and the next department 3 employees, like that. So we'll group by dname and then order by second column, the count of the employees descending. Is this clear? Let's query this. Now write it, run. So when I run, see here, department name, sales, 6 employees, research, 5 employees, accounting, 3 employees. So this is like the count of the number of words, letters, number of words in Gettysburg Address. So count of the number of employees in each department. Here, this column, when I say group by dname, will occur uniquely once. I repeat that. Group by dname. I'm fetching dname, but I'm also grouping by dname. It will occur uniquely once. And then the count will go against each of that department name. So there are 6 employees in 5 employees in research, 6 employees in sales, 3 employees in accounting. Are you able to get this output, Shira?
Yes.
Very good. Okay, so let's get back to the script. Now, having these select statements where the where clause is joining. Now, see, select start from M where manager is null, is a criteria. So where manager is blank. That means an employee who does not have a manager at all. That is the president of the company. He does not have a manager. So where MGR is null, we are selecting from M table. So let's see this. Yeah, King, the president, does not report to anybody. And so he's without, the president is without any employee, without reporting to any employee. He leads the organization and he's in 10. His salary information is given so far. Okay, so we got this query, but the middle 2 queries, we'll pick this one, aggregate function to check the count. We did take that, right? Now here, watch carefully. Both these queries are same till group by. See this. Group by D name. Here also group by D name. But further to grouping, I want to give one more criteria, having count star greater than 3. That means having more than 3 employees. Order by 2 descending is all the same. So more than, so you're grouping, and then you're going to fetch only records which are more than 3 employees. Just give me a moment. SQLite browser, paste this. The first is this one. It fetches 3 rows with the count, but there are 2 departments which are like sales and research where more than 3 employees are there. More than 3 employees. So here is 6 and 5. Accounting has 3 employees. So what I do is I give a criteria after group by the name having. So this having clause is to further filter. Actually, first filter is with the where clause. Okay, where manager is null. That means where the column is null. So this is a where clause or criteria, okay, of the selected employees results. It will further filter. What does the where clause do? Filters record. It filtered the person who does not have the manager. So whereas having is after grouping by, further if you want to say, I am looking only at employees above 3 count of department, only at department where the number of employees is greater than 3. That is what we are doing, is having count star greater than 3. Count star greater than 3. So then accounting will not be fetched. Watch. So after group by, immediately below that, having count star, that means entire rows greater than 3. So let's run this. You get the answer? Okay, get some syntax error. Having count star. So when you say having count star, this one. Run. Yeah, you got 2 rows. See, sales and research, 6 and 5 respectively. And accounting is not picked because it has got 3 rows. Whereas we required where count of the employees greater than 3. Are you getting the 2 rows, Veera?
Yes.
Any questions so far?
Um, no.
No. Here is one last thing. I want to generate an output where select employee name and the manager name. So Blake has a manager king. I want to give an output employee 1 has a manager and the manager 1. Employee 2 has a manager, could be employee 2 or employee 1 itself. The manager can. So here this sort of an output I need. So to get this, I need to alias the table M twice because the data is in still one table for employee information. It is occurring only in the employee table. So I am making 2 copies of the same table, calling it one as employee, another as manager, and joining these 2 tables now. This is, think of it as M1, M2. When I join, I have a criteria and where clause, this is called the where clause, followed by a criteria. This is the where clause criteria. What does the criteria say? ml.mgr is equal to magr.emp number. So it's called a self join because it's joining to the same table, but treating it as 2 separate tables, copies, 2 separate copies, where employees manager is equal to the manager table's employee number. The manager table's employee number. So that record will come. Okay. And then we are giving emp name. So such an employee has a manager of the name like that. self join. Such a join of a table to itself is called self join. Self join. Okay. So select ML. Think of this as employee table, and that's the manager table. And join together where employees MGR code is equal to managers employee. Hope you understand this and run that. So I get 13 rows. See, Blake has a manager king, Clark has a manager king, Jones has manager king, Scott has a manager Jones. So Scott is in the same department, but his manager is Jones. Are you getting that? You know?
Yes.
Okay. So likewise, Alan, Blake, Ward, manager, Martin, Blake, James, Blake, Adams, sorry, Turner, Blake, Adams, Scott, James has a manager, Blake. So there is a multiple levels appearing. James reports to Blake. Blake, in fact, could be reporting to a higher. Okay. Blake reports to King. So there is 3 levels there. So that's what a self join is. It's a join of a table to itself with alias names like this. The alias name is appearing next to the employee name in the from keyword. Any questions, Srira?
No.
You want to share your screen?
Sure.
Zoom it up a bit, please. Okay, yeah, there you go. You got the output. Okay. Has a manager. So if you see, there is a, in the first line, select ML name. That means you're fetching Blake, Clark, that column. Double pipe symbol. This is a way a string can get concatenated or joined with this column. So we have a simple string which is has a manager and then employee. Then it's his manager name's manager. So that's what it is doing. Has a manager. But this string is attached to the employee number, sorry, employee name with a concatenation symbol. This is called a double pipe or concatenation symbol. It joins the string column employee name with has a manager constant plain string. So this is a self join. Why it's called a self join? It's a join of the table to itself with the relationship L.mgr. L.mgr is equal to the mgr. MAGR, I've given a name like that, dot manager. So MAGR dot employee name is going to be fetched as a manager name. And then this is a criteria which is joined. Employee tables manager column, MGR column is equal to managers tables employee number. Okay, are you, yeah, you're getting that? Correct. Okay. So This some hands-on, so some basic exercise on uh, SQL statements, and we have to delete records. Let's see. Typically, we don't easily delete records, but you can delete from a table name. The row will go away. Rows will go away. Okay. So for now, you don't need to delete, but I can show that to you as well. Delete from emp, all records will go away. Okay. Anyway, this session is an interactive session with the extend. It's an interactive SQLite browser. Basically, because you don't have to install anything and you're ready to try out SQL statements. Typically, in the in a database like Oracle database, you will have to install the database, start it up and running, and then only you can go to the SQL prompt and run some SQL statements to do what we created. A query to insert rows, okay, to create a table, so on. No problem. So this is some basics, okay. Any questions so far?
Um, no.
It's not typically a common thing, but it's some administrator might create these database objects. These are also tables, also called database objects. Here, department emp. Somebody would create it, or now as a developer, you can create your own tables. Okay. Okay, and insert records, query them, join them, group them. So typically this queries which we are running with the join will go into an output of a report because the query is fetching back data. The records which show up can be presented as a report. Okay, so a report is nothing but a query. Okay, so for now that should be sufficient. Let's see a recap here. I'll give. We have, okay, let me present, I share the screen. You can stop sharing. A quick recap. So we saw in the beginning what a database is and then what a SQL is. Database collection of records into rows and columns in a database object called table. Okay, it's a logical representation of the data in tables. Physically, there are some physical files, the database files. Okay, records are identified in table as a primary key, which is an index. Okay, it's uniquely, what does the primary key do? Uniquely access the rows of that table. Okay, and then there are connection database parameters in a INI file, which is an initiation file, and so on. So we saw what is an RDBMS and a DBMS. DBMS is managing things like queries, whatever queries you're firing, it will just take the requests and do the operations of fetching the data from the disks, from those tables, and so on. Okay. So DBMS, a database management system, does all the things like creation of objects. It's basically a background processes which can do several other operations like memory, managing the read, write, and so on. Okay. And then you have a relational database management system. Relatively, there are a couple of types of relationship: primary key, foreign key, one-to-one, one-to-many, many-to-many relationship. So primary key of one table is unique, having unique key column, and a foreign key is the ref. It's a key, is a table having a key which refers the primary key table. So foreign key can repeat in the other table. The foreign key can repeat in the second table, but that foreign key is referencing the primary key. Okay. So this is called referential integrity constraint. Database schema is a collection of tables. This could be a schema, but here what we are seeing is an entity relationship diagram. We saw like one-to-many relationship, many-to-many relationship. The normalization. Normalized tables are tables where all columns are present with all the data, but you don't get, you'll have to store multiple single data multiple times will be repeating, and that repetition can lead to a very large database. Okay, so normalization is a process of taking this unnormalized data, which is having redundancy, which is repeating, into smaller tables, data in separate tables. Okay, so this whole process of unnormalized to smaller referential integrity constrained uh, smaller tables which are related to each other is called normalization. Why it's done? To reduce redundancy of storage of data. We saw modern application use NoSQL database, which is an unnormalized relational model still, like MongoDB and all that. Okay, so Postgres administrator gets a console like this. He can, administrator is a super user of the system. He can refer to any table, any record. He can use a query tool. It's like a database administrator. Okay. He is a database administrator, but typically a super user. Okay. Who's an administrator of the database. We saw how the database administrator creates the database, supplier database. And this has some connection information from Python. Okay. Parameters like username, password, what is the name of the database, are inside the database INI file, which the RDBMS reads to start the database. Okay. Start a specific database. Then we saw structured query language. Query is a question you ask the database. It's used by Relational Database Management System, the RDBMS. SQL has a syntax and based on ANSI and ISO standards. With SQL, you can do CRUD operations like create, read, update, delete. Okay. We didn't see much of update and delete, but that's also some statements, SQL statements. Okay. We saw just create, insert, and read. Read is select. Read is typically a select statement. Okay. So commonly called CRUD operations. Okay. And this is the syntax of a SQL statement for creating a table. Okay. Then once you create a table, you insert some rows into it, and then you select star from student where gender is equal to column equal to data. So it will filter. The where clause will act as a filter. Select star means all columns. The insert statement inserts values into the tables. Okay. Insert into table name values like that. Okay. So column names. Then here is person. Then select with the where clause. And then we have seen some aggregate function of which we have seen count star, counting the number of employees in the department. So here is a hands-on session which we just. So that completes our SQL coverage. Okay. Okay, Sriram, are you this just the familiarity which you need? Though we will not be doing too much of SQL, it's a session where we build applications. Some awareness is required.
Okay.
So, yeah, the department table, employee table, join output, grouped results. Like, yeah, that's the end of it. So, yeah, you can save this interactive browser uh, session for SQL. It will not be permanent. Whatever you try out here will erase off and go, but it can, with a login, it can allow you to save, and the database will not be available once it is session is closed. Okay. Okay, so that's it. So what we'll do is we'll continue in the next class. Okay, is that fine? We we will continue the next session uh, on the next week. Okay, so I will wrap it up here. Uh, the application development framework will start in the following session. Let me get to the Google. Okay, are you able to see my screen?
Yes.
So yeah, we are here, database concepts. Okay, we just finished that. We'll start with frameworks, which is introduction. So basic understanding of a development framework. What is the concept of the MVT, ORMs, and all that. MVT standing for Model View Template. So some of the web concepts in terms of a development framework is what the next session is about. Okay, so I do have some visitors, but let me just uh, stop the session here. Okay, and we'll continue with framework on the next session. Okay. Okay, Sriram.
All right, Ajit sir.
All right. So next class we'll be going into um, Flask as well, where we'll use the PyCharm IDE once again. But initially, some concept is there, which is there in some deck here. Okay, Sriram, take care. Bye.
Okay.
Yeah, thank you. Bye.
Have a good day.
Good day. You too. Thank you.